Hello everyone, in previous video I've mentioned that I want to make a small 8-inch notebook, and so the design is mostly complete. It's probably most advanced and most complicated, maybe even design I have ever made, at least electronics wise. Still, it is pretty simple because the most complicated part is done by the compute module that I'm using. So I'm not like doing CPU to memory and to flash and stuff like that. And I don't want to cover the design too much. You can look at the schematic. This is like block overview, but there is pretty much nothing really interesting here. I guess most interesting thing is power management, which is implemented like from scratch pretty much. So, but it is simple. It's just a lot of research. Like even the USB hub, it's very simple, and this is just GPIO to some M2 connector. But I can go over this in a separate video, I guess. Now, immediately when I started, I realized one thing, and that is that I will be probably having to do some slots in the board, and so I need some kind of simple mill, like simple enough to do this thing at least, but also like precise drilling, even though these vias are absolutely huge. Like the hole is 0.6 millimeter. It's actually 0.8, so I should change this, but anyway, and the diameter is 2 millimeters, so these are absolutely huge. So I've made this machine very quickly, and this is made from stainless steel profiles that I had laying around, and the only alignment I had to do basically is to ensure that this is perpendicular, this L shape, and I have done it by simply abusing it on this side. Basically, when I lay a bead there, it contracts and the whole thing bends basically. So I've done a few beats and now it should be quite perpendicular. And also I have used hidden rail for this because I want to do these things and I need to broach them with sharpened tool like this, but there's for another video. But anyway, this thing works. It's not very rigid, obviously. This is some very cheap Dremel. I guess there is probably some play in these bearings. The handle looks like it looks. This is deliberately made so it retains position, because I can use this for milling small holes. Like the slots, I basically milled and moved the board a little bit and mill it again. I've also added borescope here because I had it lying it around, because when my car was broken I bought it, and then what I will do with it. So I basically have done I've basically connected it to computer. Like in OBS I made a small crosshair that I can align. So basically what I do is I drill the hole, then I align the cross with the hole, and then I can move the board here and I can see what's happening, I guess you can say. It's not super precise, but it works fine for my needs, I guess. So with technology demo I have made this board. This is demonstrating few things. First of all, the ability to make fine traces with fine pitch. The second thing is that it works, obviously, and it does. The third thing is, I guess, the board alignment, because if you consider via here, it is quite centered, and when I flip it, it is centered again. And this is done simply by sending one edge flat, then I got some straight edge, and end mill is rotating here, and I just drove this board and basically cut the size. There is evidence of that process here. It is tricky. I do have a saw for cutting PCBs, but it is abrasive and it does heat up the copper near the cut, and the result is that the photoresist properties are modified by that process, so that is not great for this. So as I said, this board works. Also the HDMI, I was afraid a little bit, because this is not only fine pitch but high frequency bus basically, so you are playing with magic here pretty much. The USB also works. This is USB 3, so That's good. That's great. I did not benchmark this, but obviously if HDMI works great, then USB 3 will work probably too, but anyway. So with this thing working, the next obvious step is to glue power management onto here. So I have made this board. This was not working correctly, so I have cannibalized components from here. Basically I had a charging chip here. The datasheet said that it communicates with USB 3 and stuff like that. So it has like CC lines, it communicates via data lines, so there was USB multiplexer here. But guess what? The bloody chip only works with USB 3. So if you plug in USB-C with power delivery, it doesn't know what to do. It cannot negotiate some power. It can take 16 volts input voltage, so you would assume that it can do USB power delivery, but guess what? It can't. Fucking who needs that chip? Anyway. There is 80 mega 32U4 chip, like Arduino basically, and this is a boost converter. Like, this part worked great. This chip, I mean, it worked also, but like, you cannot use PD adapters. So that was shit. So this is new power management chip. This time I have made modifications. I have used STUSB 4500 here, and I did not actually properly test if this can like negotiate high power, but anyway, this time this is missing boost converter because I have already tested it, so I don't need to do that anymore. This is the same battery charger chip, and I have added power measurement chip here because I want to be able to say how much power I consume or how much power I'm using for charging the battery. Even though when the USB-C is connected, you cannot really distinguish the power consumption and charging power, so... But anyway, that's fine. So at this point I need to write code for this chip, firmware, basically to communicate with this chip to allow power to go in, and I need to configure maximum charge current based on what this is like negotiated with USB-C. And so yeah, and that's about it. So next step was USB hub. I have never done this before, so I have grabbed some random chip from Cyprus. This ended up not working correctly. I think these both chips are fried. I have only two left, I think. Now this may look that a lot of mistakes have been made, but actually what I need to do here is just stitch the ground planes, because if you look at this thing, it is pretty much exact cutout from this section of the board. So what I have done basically is I got this whole board and I aligned it with like a board like this thing, and just expose it on the small board. Same goes for the power management pretty much. The reason for trouble with this chip is because the datasheet is absolute dog shit. It basically has internal 3.3 volt regulator, and it has like analog and digital inputs. Like the analog inputs are like marked as A, like suffix, and digital as D suffix, which is like obvious, but also it has like 4 ports. So is it A, B, C, D? Like what the fuck is going on here? Anyway, motherfucker has like absolute maximum ratings for the analog and digital ports as 3.3 volts plus something. So I fed it with 5, probably is dead. I will test it on this board probably, but yeah, I don't have time for that right now. Anyway, lesson learned twice, I guess. Now there is also sound interface, which I did not test, and the PCI Express I did not test as well because it needs a lot of traces, and it's complicated to test it on like small board anyway. So I will hope for the best, I guess you can say. And actually I did test the sound interface. You know how? So I basically got the development board and I soldered a resistor and capacitor on a thing like this, connected it here. The datasheet said that it's just filter with RC network, so okay. And then I just did this with this thing grounded, and I just listened. That's how I tested the sound interface. So I don't expect any trouble, even though I forgot to mention one thing. If you look at these boards, like there is one thing that is very obvious that needs to be like improved. They are ugly as hell, and so The obvious solution for this is to use solder mask, because these connectors are so tricky to like solder by hand. I don't want to use hot air gun on like plastic parts. This is really something that I don't like to do. Like if you do this on the USB-C connector, you will burn it down basically. So that's not good. Also, I don't use solder paste because I don't know, maybe this is just a bad experience with like shitty solder paste, but I had some solder paste, it I guess oxidized or something, and then when I tried to solder something, it was exploding, so I was like, what the fuck is with this? So I associated the solder paste with this behavior, and I don't use them. Maybe they are good now. So finally I have made the board. I have actually made three, because this was my first attempt. Actually, this was my first attempt. The exposure was not great, so I was like, well, actually, maybe exposure was fine, but I underdeveloped it. So I was etching it, and I saw that something is not etching correctly. I brought it back, developed it again a little bit more, and this was the result. Anyway, so I was like, let's try to learn at least on the second layer and do this again. So yeah, this looks good. Apart from this is the bad solder mask really, because I've ordered 1 meter and they sold me like the last remaining bit on the roll, I guess. Anyway, the second attempt was this one. Actually, I have done this again because I saw that there were things not etching. I think they were here. Then I developed it again, and now this part was completely fucked up. So this is my final board. You can see that it is ugly, and that is because I had trouble with solder mask now. Basically the problem here was that the tent vias options is on by default when I am plotting. So each time I have to remember to not tent the vias, because I need to use rivets to do vias basically. Fortunately, there's not too many vias because there's nothing on the other side pretty much, so yeah. Speaking of solder masks, you can see that there are some unconventional things that I have done. For example, on this chip I have made a rectangle, and same on all like SMD chips. Also on some parts like here and on the like M2 connector I have made the rectangles. And this is because I was smart enough to try doing something with the solder mask, and I have tried to use similar trick as these Arduino boards do use, and that is to mask the bottom part and run tracks under the mask. The result was that I was not able to get solder on pads under this chip basically. Like it was completely impossible. I guess with paste it would be fine, but the difference between these two things is probably that this solder mask is 75 microns thick, whereas this could be like 30 or even 20 to save costs maybe. And also maybe the problem was because I've tried to do cold lamination of the foil here, because I had trouble with air pockets, but then I realized that I could like do lamination and gluing of the foil in the same process basically. So I just glued this very tiny edge where there is no copper. Then I put this into hot laminator, and I basically hold the foil so it is gluing under pressure. And I'm using standard laminator for A4 papers basically. Speaking of solder masks, and I wanted to do a separate video on this, and I will probably clip this out and make a short video. These are bad, this is usable, and this is so far best I've tried. So these are very cheap and highly available, but they have a bunch of problems. First of all, the adhesion is very poor. Second of all, you need to find a way to make a nice layer on the board, which is not too hard. I've tried using paint roller, and it provides very nice uniform surface. It has an orange peel texture, but it's not very offensive. It is very fine. It's actually even quite nice, I would say. Like unique, I would say. The other problem is the UV sensitivity. This you need, first of all, you need high power light to properly harden these, because on my 3D printer I was not able to get these hard at all. Second thing is resolution. It is very poor with these. And finally, if you go with method that you cover the board with some plastic film, when these are curing, they are off-gassing, so you will always have bubbles. So using this for like spot repairs or things like that, absolutely fine, no problem with that. But for covering the whole board and using it as a mask, absolutely no. I have done a bunch of testing with this yellow ink. I mean, you can see how much I have used, and you get results like this. So at first everything looks okay. The mechanical resistance is not very great, and when you hit the board up, you get like blisters like this. You can basically remove it in chunks, like this one as well. It is basically not adhering to the board very well. This is green one. It is on plain copper, so there is no like epoxy this can be bonded to very well. The mechanical resistance, it's a little bit better, but still it is about what you would expect, but the adhesion is quite good. And as far as heat resistance, it is stuck there quite well. Yeah, this is well hot enough that even the solder mask melts the solder. Finally, there is a solution that nobody uses because it's not great, but it works, and the results are not that bad. It's definitely better than those inks that I showed you first time. First of all, this is spray, so you can expect non-uniform coverage and stuff like that. The boards are quite ugly, not only because of non-uniform coverage, but also because of color. Like, this is like brown. The mechanical resistance is actually great. The resolution is absolutely excellent, same as the green stuff. And you need to bake this board at like 160 degrees Celsius to get this effect. Otherwise, it is the basic beach photoresist that you use for etching copper. The bad and good thing about this is the thickness, because you cannot really feel it, so it's probably few microns thick at most. And price, it is dirt cheap. What's a bit unfortunate about these fall photoresists is that you cannot get them in different color here and in different thickness, because there's only green 75 micron film and that's it. So otherwise this would be absolutely perfect. Originally I wanted to have front red and back blue, so it would have similar look as here, but yeah, that won't happen, I guess. Electronics wise, there's a bunch of stuff to do really. I need to design keyboard for this thing, which is not really that difficult, I guess. It's more a mechanical issue. But I need to reverse engineer this display driver, because I cannot afford having this big board there. So I've ordered 0.5mm board. I will have to replace these inductors with small profile ones, and I need to make a direct connection from this board to the LCD display, because there's also some other board that has connection from flat cable to like board to board interconnect. Because I've tested that having this chip only is enough with bunch of power stuff, but the display needs some arcane reset sequencing basically, so I've removed a bunch of passives from one board like this, and now it's not working, so I need to revive it, understand how it is done, and basically do that. But that will be another video, I guess. I will get to soldering this bad boy and see if everything works.